So now that I've brought up the topic of food, let's look at how the organic acids in sake play with food. One interesting example is how organic acids can actually get rid of certain odors in food. And one of those odors in particular is called trimethylamine. And this is a stinky compound that's responsible for the fishiness of seafood. And many of these organic carboxylic acids are capable of getting rid of the odor of trimethylamine. But the champion is really succinic acid, and it's capable of neutralizing almost 60% of the odor of TMA. So using a cooking sake that has a lot of succinate or succinic acid in it is really useful, especially if you're cooking seafood. And this is something that I do all the time, which is, give fish when I'm going to grill it or something, douse of cooking sake, and it really takes away some of the fishy odor, especially my partner, even though he's Japanese, does not like fish, and he's able to eat fish if I treat it with cooking sake first. Another interesting topic is how the acids in sake and wine interact with umami. Now, this is from a study that was done looking at a lot of different umami containing foods such as cheese and miso and dashi, and how the umami of them, how the umami perception of them changed when consumed with sake or wine. And these were actually done with, the first part of the study was done with an electronic sensor. And so these are the results for 4 different sake versus 4 different wines. And we can see that overall the umami intensity or umami retention of sake paired with cheese in this case is notably higher than that of wine. And this was generally true for all of the foodstuffs that the researchers looked at. So then they did another experiment where they actually added 1,000 milligrams per liter of tartaric, malic, and succinic acid to a sake and looked at how the umami intensity changed with that. And we can see here that added tartaric acid had the biggest effect on reducing the umami intensity and umami retention when consumed with cheese. And remember, tartaric acid is not naturally present in sake, and it's only present in wine. And so to check whether this would also be perceived by human subjects, they added 1,500 milligrams per liter of tartaric acid to a sake and had panelists taste it with cheese, and significantly fewer of the panelists felt that the umami was retained with tartaric acid present than when it was not present. So this is not to say that, either sake or wine is better necessarily, but you might want to think about this if you want to cleanse the palate and clear the flavor from the tongue, then wine might be a better choice. If you want to enjoy the lasting flavor and umami on the tongue, then sake might be a better choice than wine. So now let's take a look at how temperature affects the perception of organic acids. This is from an experiment where researchers created a model sake containing the 3 main organic acids and glucose and 15% alcohol for an overall acidity value of 3.0. And they gave this to a panel of tasters at 5 different temperatures, and the panelists gave their perception of the overall intensity of the acidity and also the quality of the acidity. As we can see, the overall intensity basically increased with increasing temperature. But as for the quality, there were some interesting results. So for the model sake at 10 degrees Celsius, the comments were that it was a fresh acidity, but also somewhat astringent. At 20 degrees Celsius, they felt that the acidity was soft and there was a mellow sweetness. At 37 degrees, this was where the acidity was most balanced and overall less bitter. At 43 degrees, they felt that this was a clean acidity and also balanced with the umami. And finally, at 50 degrees, the acidity was perceived as strong, but also with some lingering bitterness. So you might want to keep this in mind when thinking about at what temperature to serve sake that has, more or less of certain specific organic acids. For example, personally, I would choose to serve something that has a lot of malic or citric acid at a lower temperature to kind of enhance that fresh crispness. Whereas something that has a lot of lactic or succinic acid, these acids can be perceived as astringent and somewhat bitter at lower temperatures. And so room temperature or warmer can help bring out more of the mellowness and umami, especially when there are amino acids and sugars present that can help balance out the strong acidity of that lactic and succinic acid. For the final topic today, I want to talk about how these organic acids can actually change with aging. And what's interesting is that over time, the organic acids present in sake can react with alcohol to form the ethyl esters of the carboxylic acid. And the two most important are ethyl lactate, which has the aroma of ripe fruit, and also it's said to resemble butterscotch. And another is diethyl succinate, which also has kind of a fruity floral aroma and is also present in wine, so it has a bit of a wine-like quality. Now, actually, these compounds, although they can be present in aged sake, there are a lot of other more strongly aromatic compounds in aged sake, such as sotalone and aldehydes and even sulfides, that can kind of make it difficult to perceive these ethyl esters of carboxylic acids on their own. But we can make an interesting comparison with aged sake and the Korean alcohol known as chonju or yakju. Now, I don't know exactly why, and it may be because yakju or chongju actually is fermented for about 100 days, and then that's fermented for 100 days, and then also aged for another at least 90 days. And so it has a lot more complexity in terms of the amount of different esters that are present, and also the amount of these ethyl esters of the organic acids. And so if we compare the amounts of ethyl lactate and diethyl succinate in sake that's been aged for 10 years, and I took the maximum odor activity value out of the 30 sake that were measured. And then on the left-hand side is the average odor activity values of these two compounds among 8 different changju. And as we can see, although ethyl lactate is above the threshold value for detection in sake, in the average values for chongju are much, much higher, and so they are much more readily appreciated in these Korean alcohols. And so I have an example here of a Korean gwaha-ju. I don't know if I'm pronouncing that correctly. And this is from Pungjeong Sagye, which is a brewery in kind of the center east part of Korea. And I was able to meet the brewer actually at an event in Tokyo back in March. And This is actually it's a yakju, to which soju is added to stop the fermentation, kind of like similar to a kijoshu in Japan with sake. And this has just a beautiful golden, beautiful color. And it's interesting, this is made in the summer, uh, or it's made for the summer to preserve the alcohol in the hotter months of the year. So it has a higher ABV of 18%. And really interesting, beautiful, ripe fruit. Subtle caramel from maybe some Maillard reaction, which is giving it this color. But also, yeah, a little bit of butteriness. Not like the butteriness of diacetyl or something like that, but kind of like a rich aroma. So a combination of fruit and caramel and rich, but also still a little bit fresh. Mmm, mmm, mmm. Whoa. Okay. Quite sweet, quite acidic. Especially this brewery is really interesting. They make four products that highlight the seasonal nature of and variety of Korean um, brewed and fermented alcohol. So they have a really cool concept, and the brewer is a really nice guy. I mean, this is a little thick on its own. The texture is also a little bit thick. Um, and yeah, some high alcohol burn in the finish. Not burn, more just like heat. So I think it's something that would totally be amenable to drinking with a few cubes of ice or with soda or, even with some added fruit or herbs in the summer. Really versatile. It would be great with chilled meat dishes, with Chinese food, with spicy Korean food, hamburgers, almost anything that you could throw at this actually. So really interesting, and I'm sure that there are a lot of those ethyl esters of the uh, acids in here because of the high acidity. So if you want to get kind of a sense of what they smell like, maybe reach for a Korean alcohol. So as always, I hope that I was able to answer some of the questions that you might have had about organic acids in sake. And there was, I could have done, another series on this because there's a lot of stuff I left out. And so maybe that those will be things that I will get to in some other videos in the future. But I hope that this helps you when you're appreciating sake and when you're deciding how to pair or what temperature to drink a sake, and gives you a little bit more insight into the roles that these organic acids are playing in the overall profile. And as always, smash that like button and subscribe if you were interested in this content. And until next time, keep exploring sake.